Wind resistance at this height is the challenge.
The spiral minimizes the vortices. Look at the airflow.
But these red vectors show unacceptable stress concentrations here.
The rotation needs to be calculated with extreme precision, floor by floor.
Even a few degrees too much could compromise constructability.
Structural engineers analyze load paths flowing through the central core and outer megacolumns. Stress visualization.
Crashes. This soft clay layer poses a serious foundation challenge.
We have to account for the groundwater migration.
This gray clay layer starts at 3 meters. If we get any shift in this strata,
the load transfer mechanism here is critical for minimizing settlement.
Agreed. The foundation has to perform like a deep anchor to handle these forces.
Stretch the tape to the 5th stake.
Holding tension now. Is this the spiral mark?
That's it. Secure it there. Ensure the excavation depth and sequencing match the diagram precisely.
And remember, every movement must be controlled. Thermal readings are spiking in the central slab. Initiate cooling protocols immediately. Confirmed. Temperatures stabilizing now.
The schematic overlay confirms alignment within tolerance.
Data logs verify the specifications. We are clear for approval. A dramatic low-angle shot looks upward from the foundation. The scale hints at the height that will soon follow.
The central concrete core continues rising rapidly above the podium. Slip-form systems climb upward without...
Structural floors extend outward from the core, slightly rotated from the level below. Massive steel megacolumns are lifted into place around the core. These columns follow the spiral path as they rise from it. Each new floor rotates a few degrees relative to the one below. Engineers verify rotation angles before entrance. Concrete is pumped vertically to unprecedented heights. Pressure systems work at their limits to keep flow consistent. Tower cranes are raised higher as the structure grows. Each crane becomes part of the building itself. Without them, progress would stop instantly.
Secure that joint. Drilling the connection now. Clear the area below.
Concrete samples are tested directly on upper floors. Engineers verify strength before allowing further progress.
The vertical transport system is accelerating as planned.
All efficiency metrics are stabilizing in the green. We are on schedule. High-speed construction elevators move workers and materials upward. The vertical journey itself becomes an engineering challenge. As the tower rises, its floor plates gradually reduce in size. This tapering reduces Special mechanical floors are installed at intervals. These floors support critical building systems. They also strengthen the structure. The structural integrity reports are stabilizing, but look at the load transfer analysis.
Aerial views show the tower dominating the surrounding skyline. The city appears small beneath it. Shanghai Tower now defines the horizon.
All right, crane, bring it in slow. Watch the wind. Steady, steady. Lowering now. It's set. Secure the clamps.
Steps. A time-lapse shows the tower rising through day and night. Lights trace its spiral path.
The top of the structure approaches its designed limit. Crane movements become slower and more deliberate. Margin for error disappears.
Close-ups reveal complex steel connections at height.
The twisting tower cuts through a glowing sunset sky. Its spiral shape casts long...
Temporary working platforms are dismantled and lifted away. The structure stands more exposed than ever. The tower now supports itself.
The highest occupied floors are finished structurally. Only the crown remains above. Human space reaches extreme altitude.
The highest occupied floors are finished structurally. Only the crown remains above.
From a distance, the full spiral form is now visible. The tower twists elegantly into the sky.
The simulations show the vortex shedding is completely mitigated.
It's performing exactly as intended.
Cranes reposition for their final tasks. Each lift is carefully planned and executed. This phase demands total focus. With the skeleton complete, Focus shifts to enclosure. The raw structure awaits its outer skin. The next phase begins. Digital overlays preview the double-skin glass facade. Inner and outer layers appear separated by air gaps. Energy efficiency drives this design.
The tower now clearly dominates Shanghai's skyline. Other skyscrapers appear small by comparison.
Final confirmation on the facade connection points.
Measurements verified. All systems nominal.
Excellent. Proceed with the sealing sequence. First light touches the uppermost floors. The spiral catches golden highlights. The tower feels alive.
Final inspection shows all elements documented and approved.
Structural construction is officially concluded. Well done.
The camera pulls away from the raw structure. The next phase will seal and activate the tower. With the structure complete, attention shifts to enclosing the tower. Facade teams prepare mounting systems along the outer.
Custom curved glass panels arrive on site. Each panel is shaped precisely to match the tower's twist. Cranes lift massive glass panels hundreds of meters upward.
Little higher on your side. Okay, bringing it up slowly, hold steady. Looks good, lock it down.
As more panels are installed, the twisting form becomes smoother. The raw structure disappears behind.
Inside the facade, ventilation pathways are installed. The air cavity helps regulate temperature and pressure.
As you can see, these sealants and gaskets are applied with absolute precision, protecting the panels against Shanghai's wind, rain, and pollution.
From a distance, half the tower is now fully enclosed. Glass reflects the city, while upper levels remain enclosed. Inside the tower, elevator rails and machinery are installed. Shanghai Tower's elevators are among the fastest.
HVAC ducts spread across floors like arteries. These systems regulate air quality and temperature.
Electrical cables and control systems are routed vertically. Power must travel safely across hundreds of meters. Sprinklers, sensors, and emergency systems are installed. Fire safety is critical in a vertical city. Every floor must respond instantly to danger. Central control rooms come online. Sensors feed data from every part of the tower. The building now thinks and reacts.
Interior framing defines office and public spaces.
Different floors are prepared for offices, hotels, and observation areas. Each zone has unique structural and service needs. Walls, floors, and ceilings receive their final finishes. Materials are selected for durability and elegance. Luxury must survive extreme height. Upper-level observation spaces take shape. These floors offer unmatched views of Shanghai. Engineering meets human experience. Structural integrity models are holding steady at 70% load. Confirmed. Energy regulation is normalizing across all primary conduits.
Elevators are tested at full speed. The vertical journey is smooth and controlled. Human comfort is measured in seconds.
Air pressure changes are monitored across floors. The double-skin facade helps stabilize conditions. Comfort is engineered, not assumed. Emergency procedures are simulated throughout the tower. Systems respond automatically and in sequence. Preparedness is built into the structure.
Only a few upper sections remain uncovered. The spiral glass form now dominates. Automated glass cleaning rigs are tested along the facade. Maintenance is planned from the beginning. Even beauty requires engineering. Every panel must be perfect. How's the ceiling on level 42?
Flawless alignment, ready for final sign-off.
Finished interiors are revealed floor by floor. Spaces feel calm despite extreme height. Engineering creates comfort.
All building systems run simultaneously. The tower operates as a unified organism. This is no longer a construction site.
The facade is fully complete from base to crown. Glass reflects sky, city, and movement.
Upper-level observation spaces take shape. These floors offer unmatched views of Shanghai. Engineering meets human experience. All building systems run simultaneously. The tower operates as a unified organism. This is no longer a construction site.
It's operational. The transition to legacy is complete.
The hardest work is done. We delivered on time.
Reflections of Shanghai move across the curved glass facade.
It's a city stacked vertically. Offices, public spaces, and observation areas operating simultaneously.
All systems are optimal. We are confirmed ready for full operation.
Approved. Let's power up.
Final preparations conclude. The tower awaits its official unveiling. A new icon is ready.
The camera slowly pulls away from the completed facade. The final phase will reflect on testing, opening.
Sensors embedded throughout the tower transmit real-time data. Engineers observe minute movements caused by wind.
Controlled load tests are performed across multiple floors. Weights simulate years of real-world use. The structure responds exactly as predicted. Strong wind conditions are monitored around the tower. The spiral form visibly reduces turbulence and vibration. Design theory is fully validated.
Селі невістарух. Містатичен статит нефета силти спиличими шлетидия. И не глез пылвы стедию сипысли соври сади трепес.
The tower now anchors the New York skyline. Its presence feels permanent and stable. A new reference point is set.
The solid base and reinforced core remain unseen but essential. Protection is integrated.
The tower does not demand attention. It earns it through presence and stability. Confidence replaces spectacle.
Engineers worldwide study this project. Urban constraints, safety, and resilience redefine standards. Knowledge spreads beyond the site.
Design priorities shift across the industry. Redundancy and resilience become normal. One building changes many. Traffic flows, people work, life continues. The tower integrates seamlessly. Belonging is achieved.
Rain, snow, and sunlight pass over the facade. The building remains unchanged. Durability is proven daily. Strength here is structural, not symbolic. Concrete, steel, and systems define resilience. Meaning emerges naturally.
Future skyscrapers follow similar principles. Security and openness coexist. A benchmark is established.
No system draws attention to itself. Everything works as intended. This is success. From planning to operation, the journey ends here. Construction fades into daily life. The cycle closes.
Time passes, seasons change. The building remains constant. Engineering outlasts moments.
Processing intensification detected. Stabilization protocol initiated. All systems clear.
The screen fades with the tower standing firm.